All right, so Google has just dropped this fascinating new blueprint for AI, and it tackles this massive problem, one that's been bugging developers for a while. How in the world do you get a bunch of smart, independent AIs to, actually work together instead of just fighting each other? Let's dive in.
So you'd think, right? Put a bunch of brilliant AIs on a team to solve a problem, and what do you get? You're probably picturing this perfect, efficient hive mind, like a symphony of pure logic. But yeah, the reality is often the exact opposite. It can get messy. Believe it or not, they often just start fighting. And I know, that sounds totally backwards. But think about it. Each individual AI is usually designed with one goal in mind: maximize its own score, its own success. And when you have a whole team of these me-first agents, they can accidentally end up tearing down the whole project. And this gets us right to the heart of the issue, what the researchers call mutual defection. It sounds pretty dramatic, right? AI agents at war. So let's break down exactly why this happens. Okay, here's a perfect example. Imagine you have two automated pricing bots for competing online stores. Both are given a simple instruction: maximize profit. So what does bot number 1 do? It lowers its price just a little to steal customers. Then bot number 2 sees that and does the same. Before you know it, they're in this destructive price war, a race to the bottom that ends up hurting everyone's profit. Each bot is doing exactly what it was told, but together, they're failing at the bigger picture. So, for a long time, the solution to this was, well, to basically put the AIs in what you could call hard-coded handcuffs. You give them this super strict rulebook that dictates every single move. But, as we're seeing now, that old method just isn't cutting it anymore. Frameworks like LangGraph, for instance, rely on these rigid state machines. It's like giving an actor a script for a play. It tells them exactly what to say and do in every single scene. And sure, that works great if the play never changes. But the real world isn't a play with a fixed script, and that's where the big limitations pop up.
And that's exactly what Google's senior research scientist, Alexander Mulemans, is getting at here. He says the problem is that these rigid systems just don't have the flexibility for the real world. I mean, think about it. The world is complex. It's messy. You literally can't write a rule for every single thing that could possibly happen. They just don't scale.
So this is where it gets really cool. The Google team decided to flip the whole problem on its head. They stopped trying to force cooperation with a rigid iron fist rulebook, and instead, they asked a totally different question. What if cooperation isn't something you program? What if it's a skill an AI can learn? And this idea was the big breakthrough. Forget the rulebook. Instead, they basically sent the AI to school. A school for social skills, you could say. They threw it into a mixed pool with all sorts of unpredictable opponents, forcing it to figure out how to get along and adapt, all by itself. And this mixed pool isn't just one type of AI. It's this whole cocktail of different partners. You've got other AIs that are actively learning, just like our agent. Then you have some static, predictable partners, and even some old-school, simple rule-based programs. This variety is the secret sauce, because it forces the AI to learn how to deal with all these different personalities and strategies. Okay, so how does this actually work? What's the magic behind the curtain? Let's get into the nitty-gritty of how these AIs are learning to cooperate. It all comes down to this really powerful concept called in-context learning. What this means is that the AI can look at the history of an interaction, the back and forth, and adapt its behavior in real time. It's figuring out the social rules as it goes, on the fly, without a human developer having to jump in and write a new hard-coded rule. Okay, but wait a second. If you're a developer, you might be thinking, isn't tracking all this history going to completely overload the AI's memory? Its context window? It's a really valid concern. Can it handle all that information? But here's what Mulemans says, and it's a critical distinction. He says their method isn't about demanding bigger context windows. It's not about giving the AI a bigger brain. It's about training the AI to use the brain it already has smarter. It learns to focus on the important parts of the conversation history, to see the patterns, which is way more efficient. So to really put this to the test, to see if it actually works, the researchers use the ultimate test of trust and cooperation, the classic prisoner's dilemma. If you're not familiar, it's a game theory puzzle where two players have to decide, round after round, whether to cooperate with their partner or betray them for a bigger personal gain. And the result? It totally worked. The AI learned to build stable, robust cooperation. And here's the amazing part. It did this even when it started with zero information about its opponents. It learned to trust from scratch, just by playing the game. That's a huge deal. So what's the big takeaway here? Well, this breakthrough isn't just about how AIs talk to each other. It's about to completely change how we, the human developers, work with them.
We're seeing this massive shift in the developer's role. The old way was being a micromanager, a rule writer, dictating every little interaction. But the new way? It's about being an environment architect. You're not writing the rules of the conversation. You're designing the school where the AIs learn the rules of conversation. You're setting the stage, defining the training, and then stepping back to provide that high-level oversight.
And Wheeleman sums it up perfectly. He says the developer's role is evolving into a more strategic one. Your job isn't to code for every specific outcome, but to define the broad training parameters that ensure these agents learn to be helpful, safe, and collaborative, no matter what crazy situation you throw them into.
Which really leaves us with this huge, powerful question to think about, right? If we can genuinely teach AI to collaborate, what's next? What kind of massive, complex, global problems could a team of cooperative AIs solve? We're not just talking about better software anymore. We could be talking about a whole new frontier for problem solving. And honestly, the possibilities there are just staggering.